Akshit.
Hello, sir.
Are you all right now?
I'm good, sir. Actually, I had midterms, so I couldn't join the class.
Acha. Yeah, exams are going on everywhere. I know. Many students said that. I got text like, so we have midterm exam. Your exam over, Sam? Samhita? Okay, wait, like you. Okay. How was your exam? Good? You can unmute. No problem.
Yeah, it's easy only, sir.
Acha. Okay, except math. Why? What happened in math? Okay, fine. It's difficult to type so much. So let it be. You can tell me some other day. Okay, let's go back to our class. Uh, Still two members are. Let's wait. Just let me text you in group. Who am missing? I don't know, man. What's her name? Sohan. Yes, Sohan is not good. So Sohan will not come. And Madhusudan, he's also not well. Or maybe he will come late. Who left? Janvi, yeah. Mm. There is no name. Yeah. Chalo, take care. I've texted. Let them join. It's already 7. Okay. So we discussed yesterday. So guys, those who join after so many days, one quick information. We started thermodynamics. We almost finished introduction, first law, zeroth law. And today we are going to do application
To do
of,
the application of first law.
yeah, exactly. So today we are supposed to do application. Just a second, let me turn on light. Hmm? I want class. Hmm? Okay. First, we'll see melting process. Application of first law is melting process. Now, okay. When a substance melts, see when substance melts, what will happen? There is a change in volume, but it is very small. So what we'll do? We'll neglect this small change. As we discussed all this thing yesterday about the first law, how it changed and what happens there, like internal energy remains this it's a process of that, no change in internal energy, it remains same. So final initial will be equal. So for that, what is the outcome, or we can say what is the application of it, what is the use of it, where we will use. See, devices we know those like instruments and all that, but how we will use, like what is the purpose of that, that is what application means. So temperature here, temperature, substance remains unchanged during melting process. Now yesterday I was talking about two ways of understanding temperature, right? Temperature of this like whole process, but inside that metal or whatever substance it is, there might be change of temperature. Then only heat will produce, right? First thing we wrote, where is this heat? Where we wrote heat? Heat, what we wrote for heat? Transfer of heat transfer from one point to another point. So it is due to difference in temperature. So only heat is produced. So first law is based on heat only. So there is a difference in temperature inside the whatever material it is, and outside. So if we consider some all this process, or I didn't finish PROs process. If consider all this melting process, and we'll say some, let's say here heat absorbed during melting, that is little heat ml. Now L is what? Heat of fusion, and this is for mass. Let's take mass only, not unit mass. Let's consider here only mass. Temperature is constant. Now, what do you mean by latent heat of fusion? Let me write here, but first you tell me. If you know, you tell me. Come on, quickly. What do you mean by latent heat of fusion? Just tell me what is fusion. Anyone? Aditi, Janvi, Akshay, Samhita. Samhita, you want to type? If you want to type, you can. In short words also, okay. Others, yeah. Aditi, what do you mean by fusion?
So it is melting of solids into liquid and vice versa.
Vice versa is also fusion.
No, like that was given in chemistry.
Acha. Okay. But yes, that's right. So if we want like small explanation, I'll write here so that you will not forget. So okay, let me this explanation. So let me change this one. Heat required to change unit mass of solid to liquid at constant temperature. So first law, what it says, delta Q equals to delta U plus del W. Del Q plus del U plus del W. So del Q is what? M into L, which is equals to del U. Because this is U doesn't look good. Yeah. Now, what about work done? Plus work done. Now, in this process, P del V, this is equals to 0. Change of volume. There is no change of volume. So this whole term will become 0. 0. So instead of writing 0, let it be like this. So what we conclude here, internal energy increased by ml during melting. That is what our conclusion. Are you done?
Done, sir.
Done? Okay. So let's go for boiling. Now in this one, same thing we are going to write. When substance melt here, here substance melt. But, or he can say liquid is heated changes to, let's say, into vapor. Temperature. That is called boiling. Or this constant temperature, we can say boiling point also.
Sir, could you once slow?
Yeah, sure.
Done, sir.
Okay. So liquid is heated, it changes into vapor at a constant temperature. That the constant temperature is boiling point. So constant temperature and pressure. So what is the boiling point of water? Do you know? Anyone? Normal. Atmosphere. That is, what is it? No one?
100 degrees Celsius, sir.
100 degree. Very good. So in this case also, temperature remains unchanged. See, what is actually happening? We are strictly providing temperature. Okay, we are giving like if you observe that when you're boiling water, we are not changing again more and less and more and less. We are not doing anything. We are providing one fixed temperature. We don't know what is it. Okay, suppose this is our like a gas knob. From here it is 0. So we are giving it here. Okay. So whatever maximum possible, whatever it is. Let it be so high, let it be so less. Okay, doesn't matter. That is not our problem. That problem is about water only. Water's problem. So in that stove, we are putting one vessel here, that water is there. Okay. Slowly, 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 it will start heating. Temperature will change slowly, 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 slowly. Once it reach 100 degree, that is the boiling point or transfer state of that object, or sorry, water. Object in the sense water here. So this temperature, we don't know what we are providing. We need to measure it. Okay, that is not our problem now. The main thing we are considering here, that water reach the 100 degree. So whatever temperature we are providing, let it be whatever it is. Let it be fixed. Let it be 200,000, 2,000, whatever. It will get instantly. If it's 2,000, it will get instantly boiled or whatever. The only time will be varied. Depends upon this temperature. Whatever we are providing from this gas stove, the time will be varied. But this thing will be constant. Are you able to understand what I'm saying? Yeah?
Yes, sir.
Okay. So here we can say temperature is same. It is unchanged during boiling process. Now, what is happening here? Object is expanding from liquid, it's becoming vapor. So volume has changed. It is expanding. So work done in expansion. So del W equals to P del V, which is P and VL. So this is for liquid, this is for vapor, this converting into vapor. And same goes for del. So here in this one, what we wrote, heat absorbed during melting. Heat absorbed during boiling. Boiling process. So del Q equals to ml. Now what is L here? Can someone tell me what is L? There L was latent heat of fusion. Here L will be heat of. Anyone wants to try the answer? Aditi, Janvi, Akshit. Latent heat of
Is it vaporization?
yeah, vaporization. Latent heat of vaporization. So now latent heat of vaporization means from this statement can we describe same thing. What difference we'll write here? Instead of something, we'll write something else. What is it?
Liquid to gas or vapor.
Liquid to vapor at constant temperature and pressure. Same thing. Liquid to vapor. Here there is a change in internal energy also, because here like vapor as well as liquid form, they both have different internal energy. So change in du equals to uv minus ul. So del q equals to del, oh let's write directly, but okay, nice. So ml equals to uv minus ul plus, what would write here, pvv vv minus vl. So if we take this that side, so internal energy has changed into how much form, whatever it is, we can calculate. So we are not going with those like small things. Let it be. It is same thing. According to requirement, we will do it in the question itself. So we can see if you want to find, mostly we will ask to find gain in internal energy only. Alright, what is this? Mostly we'll ask to find gain in internal energy. Now let's finish this other application, small. So same way we can go for all. So I'll not write all this thing again detailed, like same thing. I'll just write directly process. So let's make a number here. Okay, we can count how many processes we do. Third one. Is there anyone writing?
No, sir.
Okay. Then isobaric process, where P is constant, dW equals to integration of V1, V2, PdV. PdV means P V2 minus V1. So all these things we can write in your dq formula. Dq in the sense first law plus dw or ncp dt. dq equals to ncp dt at constant pressure. Fourth one, cyclic process. In cyclic process, heat is given to system which is equals to work done. It is by area. Area of cycle. See, an area under the curve or cycle. So in cyclic process, heat given to the system is equals to work done. That we saw in diagram yesterday itself. Where is the diagram? Here. Then fifth, what process? Yeah, let's take this. Isothermal, we say. So temperature is constant. So work done equals to V1, V2, PdV, same thing. So P we can write as nRT log E V2 minus V1. This is constant for ideal gas. Therefore, du will be 0. If the temperature is constant, internal energy will be 0. So dq equals to dw, which is equals to same thing, especially for ideal gas. ठीक है? I'm scrolling down. Anyone? If you're not written, tell me. So in isochoric process, work done is 0 because V is constant. This means what? Same thing what we wrote above. Heat given to system which is used in increasing internal. See, I'm writing all these points so that you will remember when you're doing some numerical or some related theory. So these points are important for writing. I'm not deriving anything here. We don't want derivation here. Nothing we want. We want what is the importance of that isochoric process? What is the importance of isothermal? What is the importance of cyclic process? That's what we are writing here. Like key points. The last one we can finish here. That is adiabatic process. So in this one, heat is given or taken by system from surrounding is 0. That means dq is 0. If dq is 0, then du equals to minus dw. Minus dw and RT. So here gamma minus 1, T1 minus T2. Or other way we can write P1 V1 minus P2 V2 by gamma minus 1. So what is the conclusion of this adiabatic process? System is expanding here. See this, that's what we wrote here. System expand. dW is positive and internal energy is negative because temperature decreases. If system contract, dW is negative and du is positive. That means temperature increases. Any process we left? We wrote what? Cyclic process, isothermal, isobaric, isochoric, and adiabatic. Yeah, all done. Come on, make a note of it. Gamma is the constant, 1.4. What was the previous topic we did? I'm going to post a test today. Thermodynamics is this one. Before that, moving charge test done. One second, please. Let me just check what the portion moving charge wave. One test solid done, moving charge. Okay. I'll keep for moving charges and magnetism test tomorrow. I'll post today itself. You can attempt today itself if you want, or else tomorrow. Okay. The same 10 questions, not more than that. 10, 12 max. That's what I'll give every time. 10, 12 maximum. Last time I gave 1 to 10, no? So remaining I'll give. Yeah. Any doubt in today's session? What happened, guys? Are you there? No? Sleepy?
Yes, sir.
While taking class, you slept or what?
No, sir. I was writing notes. I was noting
Acha.
down.
Okay, okay. Fine, fine. So today only I'll post classes. Oh, sorry, test. I'll start today itself. So 24 hours it will be live as usual. 9 to 9.
Okay, sir.
Bye bye everyone.
Bye, sir.
Bye, sir.
Bye bye.